Okay, so this lesson 4.2 is going to be talking about isosceles and equilateral triangles. We are going to be talking about some new theorems. I did just write them in the notes, so you won't have to fill out a vocab sheet. But your homework tonight will also be the Savas practice. Okay, so let's just start off with what the definition of an isosceles triangle is. So that's going to be a triangle. Okay, this is in your notepad, so make sure you are filling it in. Okay, so a triangle with two congruent sides. Okay. So in other words, it kind of looks like this. Okay. So these are your two congruent sides. We also refer to the two congruent sides as your legs. So this is a leg, and then you have your base down here being the third side. Okay. So with that said, the isosceles triangle theorem is going to be basically based on the definition of an isosceles triangle. So here's what it is. It says if two sides are congruent, then the angles opposite are congruent. Okay. So in other words, if this side and that side are congruent, then you have this angle and this angle being here. These are also what are referred to as the base angles. Okay. Okay. The converse of that, okay, so if at any point you need to pause it to catch up, let me know. Okay. The converse of that is switching the if and the then. So if, okay, like if two angles are congruent, then the legs are congruent. Okay? So today we're just going to look at setting up problems and solving for that. Okay. So let's practice this. So it says using the isosceles triangle theorem, we want to find the value of x. So here's what I'm going to start with. Okay. Right now I know that this and that are congruent to each other. So in other words, I know that this angle and this angle, opposite angles, the base angles, are congruent to each other. So in other words, this would be 28 degrees. Okay. But now looking at what I have this angle up here, which is the vertex angle, and then the two base angles. All triangles, regardless of what type they are, add to 180. So how I'd set this up, I would do 5x plus 9 plus 28 plus another 28 all equals 180. Okay. And so we're just going to solve for x. So combine like terms here. You would get 5x plus 65 equals 180. Subtract 65 would be 5x equals 115. And then divide, you should get x to be 23. That's the answer for the first one. Okay. For this next one, you are given, these are your two base angles. So we know that this is congruent to that. Okay, so I know that the two base angles, the opposite angles, are going to be congruent to each other. So congruent means equal, so I would just set them equal. 4x plus 9 equals 8x minus 3. Okay. All right, and so just solving, I'm going to add the 4x over, so you get 9 equals 12x minus 3. Add the 3, you would get 12 equals 12x. And then divide, you get x equals 1. Okay, so just basic solving for x. Okay. This one, you need to be able to know which sides are congruent. Okay, so it says using the converse of the isosceles triangle theorem, we want to find the lengths of all three sides. So the first part is we need to solve for x. Okay, so here's what I'm going to start off with first. These are my two angles that are congruent. That means the sides, draw arrows here and there, are congruent to each other. So you're not going to use the 6x minus 12 yet. Okay, so how I'm going to set this up is I'm going to do 8x over 3 just equals x plus 20. Okay, I don't like fractions, so I'm going to get rid of the fraction first. So here's how I'm going to do this. I'm going to multiply both sides by 3, okay, and make sure you put parentheses around the x plus 20. This cancels out, and so I'm just left with 8x. And then when I multiply this through, you would get 3x plus 60. Okay, and then just solving for x, subtract 3x, get 5x equals 60. Divide, you get x equals 12. Okay. Okay, so then from there it says find the lengths of all three sides. So now I'm going to take x, okay, and I'm just going to plug it in for all three parts. So we'll start with PR is going to be this length right here. So it'd be just 12 plus 20, which would be PR to be 32. Okay. Then I would do RQ. So it'd be this length over here. So it'd be 8 times 12 divided by 3, which would also be 32. That makes sense because we said those were equal. And then finally for PQ, the last one, it would be 6 times 12 minus 12, which would be 60. Yeah. And so those are my 3 side lengths. Okay. Alright, so here's what I want you guys to do. I will post this answer key later, okay? But I want you guys to try this one. So try solving for the value of x, and then finally solve 3 sides. Okay, we're going to move on to theorem 4.2, which deals with bisectors. So here's what's going to be. Theorem 4.2 says if, okay, a point lies on a bisector, okay, comma, then the base cuts into 2 congruent parts. Okay, so I think the best way to show this is like through an example. Okay, but basically says if like you have a point that lies on a bisector, then that base is cut into 2 equal parts. Okay. All right, so we're going to look at this example right here. So it says use the perpendicular bisector to solve problems. So it says a prefabricated house is delivered to a foundation in 2 symmetric halves that are assembled on site. Along the planned route on the site, the truck must pass under a bridge that is a clearance of 17 feet. Should the truck plan a different route for delivering the house? Okay, so here's what we need to think about. Is if we're talking about, okay, it has to have a clearance height of 17 feet. Okay, so in other words, what we have right now is we have this bottom part right here is 10. We need to figure out this length up here because it has to clear it. Okay, so here's how this is going to look. Okay, what I know is that there's this point that lies on the bisector. Okay, I know this bottom part is 28. So I know that this part right up here, you're kind of filling it in, and I'm going to get to it in a second, is half of 28, which would be 14. Okay, I know that this length over here is 16. Here's the deal. This is a right angle right there, and I'm trying to find the height. If I pull this triangle off, I have this right here is 14, this is 16, and this is the height. I can use Pythagorean theorem. A squared plus b squared equals c squared. Okay, so like a could be 14, b could be h, and c has to be 16 because it's the diagonal. Okay, so what I would do is plug that in. Okay, you would get a squared is 14 squared plus b squared is h squared equals c squared is 16 squared, and we're solving for h. Okay. So in other words, what that would be is it would be 196 is 14 squared plus h squared equals 16 squared, 256. Okay. You're going to subtract 196, so it'd be h squared is equal to 60 Okay, and then you can round, it's okay. Take the square root, okay? Your h would be approximately, just plug in square root, 67.7, okay, feet actually. Okay, but we still have not answered the question. Okay, so now that what we know is I know that this height right here, I'm going to fill that in, okay, is 7.7, okay? You still need to check to make sure that the house clears the bridge. So the bridge is going to go over like this, okay? So what I'm going to do is I'm going to add this bottom part here of the house, which is 10, plus the height that I just found, 7.7. Okay, so it'd be 17.7, okay? But the problem is that this only has a clearance height of 17. So 17.7 is greater than 17, which means, okay, the house would not or wouldn't clear the bridge. Okay. Yeah. Okay. Okay. Let's try another one like this. All right, so here's what it says. It says use the figure shown. What is the measurement of RSQ? So let's start with labeling where RSQ is. It's the middle guy, which would be this guy right here. Okay. And so in other words, here's what I know. Okay, you kind of have to fill in what you have. You know that this part here and this part here are congruent. So I know that this angle here and this angle here are both 31. Okay. Okay. From there, what we're going to do is now I'm going to find the total angle up here. Okay, so this angle up here by doing 180, because it's a triangle, minus 31 minus 31. And so you get 118 for that purple angle. But now, looking at what I'm trying to find, this angle right in here, this is a bisector. A bisector cuts it in half. So in other words, I do 118 the whole length, just divide by 2, and so you would get 59 degrees. Okay? That's the first part. And then the other part, it says PR. So PR is going to be this full length here. Here's what I know. I know that this point's on the bisector. So based on that theorem, it cuts the base in half. So this part here and this part here are congruent. I should use 2 ticks. So that'd be 4. And so the length of PR would be just 4 plus 4, which is 8. Okay. Okay. So then this last section is going to be dealing with equilateral triangles. So let's just talk about like what an equilateral triangle is. Here's what it is. Okay, an equilateral triangle is all sides are congruent. Okay, that makes sense. Okay, so in other words, like this, 1, 2, 3, all those are equal. Okay. If a triangle is equilateral, it also means it's equiangular. So equiangular means that all angles are congruent. And actually what that means is specifically, you know that all triangles add to 180. Each angle in this equilateral triangle is each going to be 60 degrees. And that's something you can always like assume. Okay. If it's an equilateral triangle, then all angles are 60 degrees. Okay. All right, so with that said, okay, in an equilateral triangle theorem, it says this, what I just said. If 3 sides are congruent, comma, then each angle equals 60 degrees. Okay. All right, and then I'll pause there for a second. So if 3 sides are congruent, then the angles are each 60 degrees. Okay. The converse of that would just be the flip. So if, okay, the converse of the equilateral triangle theorem would be if each angle is 60 degrees, then all 3 sides are congruent. Okay. So 3 equal sides means I have 3 equal angles, meaning they're all 60. Yeah. Okay, so you gotta look at the tick marks where you're noticing. Okay, so here's what it says. It says if the measurement of CBD is 130, so CBD is this angle right here. Okay, that's 130. Okay. It's asking what is the measurement of BAD. So BAD would be this angle up here. Okay. So here's what I'm going to start off with. What I see over here is I see there's an equilateral triangle. Okay, so what I'm dealing with is angles. So I know this angle is 60, this angle is 60, and this angle is 60. Okay, just that pink part. Okay. Then what I can tell is I can tell if the whole thing down here is 130 and part of it's 60, then the measurement of A, B, D would just be 130 minus 60, which is 70 degrees. Okay? So, I'm now going to fill this in right here. That's 70 degrees. Okay? But now, I'm going to use isosceles triangle theorem. These two are congruent, meaning this angle and this angle are congruent. Now, I don't know what that is, so I'm just going to label that as x and x. They are the same value. Okay? But now, if I look, okay, don't look at the 130. I'll erase that. Okay? If I just look at this is 70, and I have two angles that are equal, I can just add x plus 70 equals 180. Okay? And then just solve. So it'd be 2x plus 70 equals 180. So subtract 2x equals 110, and then divide x is 55. Okay, it was asking you to find the measurement of BAD, but we labeled BAD as x, so it would just be 55. Okay. Okay, so this one, okay, what is the measurement of angle U? So angle U is over here, so same idea. Okay, we're going to play on this idea of where are the congruence markings. So let's start with the only number that we have labeled. We have this and that, and then we have this angle up here. Okay, opposite angles are congruent. So this angle and this angle are congruent. So I'm just going to label that as x and x. Okay. So now what I have is I have this triangle right here. All triangles add to 180. So what I would do is I would just add x twice and add that to your vertex angle 72 equals 180 and solve. So you would get 2x. I'm just going to subtract the 72 over, be 108. Divide, you get x is 54. Okay, and so what we're going to do is we're going to fill that in. Okay, so fill it in. Okay. Be 54, 54, okay. So now I'm trying to find angle U. So I have to find an angle somewhere in this triangle. Well, what I notice is right here and right here, that's a linear pair. A linear pair adds to 180. So I could just do 180 minus the angle I just found, 54, and you get 126, okay? And now, if I look at the triangle that I'm trying to find U in, right here, okay, these are two congruent markings, these are two congruent markings. So this angle here and this angle over here are congruent. I'm just going to call that y and y. Okay, so now setting up that red triangle, I would get y plus y. Okay, I can make any letter. That's what I'm just doing. I'm leaving it as like almost a placeholder. Plus the vertex angle is 126 equals 180. And so you would get 2y. If I subtract 126, I would get 54. And then divide, you get y is 27. Well, look at what I labeled as y. Y was u. Okay, so in other words, the measurement of angle u would be 27 degrees. Okay, so I'm just leaving like letters as placeholders so I can set in my equation and not just have blanks. Okay. Good. So those are kind of the hardest ones to work around. Start with the only numbers that you have labeled. Okay, if there's no numbers labeled, then look at where's the equilateral triangle. Alright, so like talking about that one, okay, it says find the measurement of each angle in the figure. So we have the measurement of PMO. It's going to be this angle over here. Okay, so here's what I'm going to start with. I have an equilateral triangle over here. That means each angle inside that triangle is 60 degrees. Okay, but now I'm trying to find that measurement PMO. PMO forms a linear pair with this angle right here. So I can just do 180 minus 60, and so that would be 120 degrees. I'm going to fill that in because I'm going to use it. Okay. And then the last one says find the measurement of NOP. So NOP is right here. Okay. So here's what I can do. This right here and this right here are two congruency markings. That means this angle O and this angle P are congruent. So what I can do is I can call this X, and then I have a triangle right in here. Okay, so it can be X plus that 120 that falls in there, which is equal to 180. Okay, and so I would get 2X equals, that would be 60. And then finally divide, you get X is equal to 30. And so that's what we labeled as the measure of NOP. It would be 30 degrees. Okay. So again, like try to figure out like where's the equilateral triangles, where are the congruency markings, the base angles are congruent, that type of thing will help you out. Okay. All right, so that is the lesson for today. So your homework tonight is going to be the lesson 4.2 Savas. Okay. Posted. There should be a link on Google Classroom. I am going to be back on Tuesday, so we need to make sure that we're doing it. Our quiz on 4.1 and 4.2 will be on Wednesday. Okay? All right, feel free to sign off. Good job.